What's up, guys? Welcome back to the channel. Welcome back to the video. Alright, this video here, guys, will be doing special angles. So with special angles, there are certain things that you need to know, guys. So I'm about to show you those things. First of all, I'm about to show you the right angle triangles for special angles, and also I'm going to show you guys how to use, I'm just going to show you a little bit of a few problems on how to use special angles given the information that we did last time, because you also need to have done some of the things that we did last time, your co-ratio rule, your 180 rule, and able to know how to use those rules as well, because here now we're going to apply that as well. Now let's start. Now the special angles, they are actually, you can demonstrate them on the right angle triangles that I'm about to show you here now. Now we have the first right angle triangle, which is like this. All right, we know that the right angle triangle, it has a right angle here. We are good. And then now this one, this right angle triangle, it has two special angles. One is 30 degrees, and the other one is 60 degrees. Now the longest side for this special triangles is supposed to be 2, right? So that is the longest side, the hypotenuse of this right angle triangle. And then the adjacent side for 30, but opposite for 60 is square root 3, and then the opposite for 30 and adjacent to 60 is 1. So that is your special angles, the right angle triangle for special angles, by the way. So the other one that we have that you need to know is this one right here. All right, with the two angles here. In fact, it's one angle, which is 45. So this one is pretty simple to remember. It's one this side, whereby the longest side is square root 2. So I'm not gonna do the other one, whereby you have 90 and 0. We hardly use that one, so I'm not gonna touch on that one. Probably gonna touch on that one later on as we continue. Now this one here, it has how many special angles? The one that you see here, we have 3 special angles. We have 30 degrees, we have 45 degrees, and the last one we have 60 degrees. These are not the only special angles, because we also have 90 and 0 as well. But we're not going to focus on 90 and 0. We hardly use those ones, guys. We hardly use those ones. Now, I'm just going to focus on these 3 because we use them all the time, almost all the time. Now, how do we use these special angles? Where do we actually use the special angles? Now, in order for us to use the special angles, now we have to use almost everything we have done with trigonometry from day 1. Now, let's look at our problem. Let's just add this problem here. Let's say we have sine 240, and they said to solve this without a calculator. How would you solve this problem without a calculator? Now, first of all, what you need to do is you look at your angle. In this case, what is your angle? Our angle is 240. Now, 240, where does 240 lie on our cast diagram? Remember the cast diagram, guys. Remember the cast diagram. Yes, the cast diagram. So we need to look at 240. Where does 240 lie in our cast diagram? What is the quadrant at which 240 is at? Now, if we look at 240, 240 is above 180, but less than 270. That will mean that 240 lies on quadrant number 3. Now 240 lies on quadrant number 3. And now when you look at how we represent quadrant number 3 on the third on our cast diagram, this is how we represent it. We use 180 plus theta or 270 minus theta. So I'm gonna do both of them on the side. Now I'm gonna start with the 180 plus theta. So you can always write it like this. Sine. Oh, before we go there, guys, before we go there, we know that is 180 plus theta, but you look at the third quadrant. Now, when you look at the third quadrant, let's look at our trigonometric function here. This trigonometric function, which is sine. Is sine positive on the third quadrant? No. So, meaning, whenever you write this, now you're gonna write the answer in negative. So, your answer is gonna be negative sine. And then how do we represent 240? Now with regarding of 180 plus, it's gonna be 180 plus. Remember, 180 plus is the third quadrant. Now you need to add one of these special angles. When you add 180 with one of these special angles, it should give you 240. All right. So how are we gonna do this one, guys? How are we gonna do this one? If we add 180 with 30, it will give us 210. That is not enough, guys. That is not enough. Meaning we have to move to another one. If we add 180 with 45, it's gonna give us 225. That is also not enough. But if we add 180 with 60, we're going to get 240. So that is the one, guys. That is actually correct. So 180 with 60, you get 240. Then you start reducing. So as you reduce, this is gonna be sine 60. Do you guys see now? This is gonna be sine 60. Now looking at our special angle triangles, sine 60 is here, guys. 60, in fact, our special angle is supposed to be on this triangle. Now, as you all know that sine is opposite over hypotenuse. So when you look at 60, what is the opposite of 60? Now, the opposite of 60 is square root 3 over, and then the hypotenuse is what here? It's gonna be 2. So your answer is negative square root 3 over 2. Now this is when you're using the 180 rule, guys. This is when you're using the 180 rule. Now when it comes to this type of problems, guys, you don't really have to use the specific rule. You can use the one that you prefer the most, which is the one that is way much easier, is actually the 180 rule. Now how about when you use the co-ratio rule? The very same problem. Let's say we have sine 240 this time, and then we say maybe use the the co-ratio rule. They say use the co-ratio rule. Now if you use the co-ratio rule here, still you need to notice where this 240 is happening. Now we all know that this 240 is happening at the third quadrant. Now how do we represent the third quadrant when we use the co-ratio rule? Is 270 minus theta, but still sine is still negative, guys. Sine is still negative. Then what is our co-ratio of sine? So the co-ratio of sine is going to be cos. Now how do we represent this 240, or how do we represent the angles in the quadrant? It's supposed to be 270 minus theta. Now let's write 270. All right, minus. Now what is the theta? What is the angle that we can insert there that when we subtract 270 we will get 240? In this case, in this case, the special angle 30, if we substitute it there, it will give us 240. So 270 minus 30, it will give us 240. So let's substitute there. Let's change the color. Let's change the color, guys. There we go. Now we will have this. Now if you continue, your answer is going to be negative cos 30. Now when you look at your special angles on their triangle, again, where is 30? 30 is here on the first triangle there, the right angle triangle there. Now when you look at it, how are you gonna solve it? Now if you still remember, cos is adjacent over hypotenuse. Now what is adjacent of 30 on that triangle? We know that the adjacent is square root 3 over, what is our hypotenuse? It's 2. Let's not forget the negative sign there. All right, so as you can see, this gave us the very same answer. By the way, this is a co-ratio rule, guys. All right, this is a co-ratio rule. So the difference here is that you have to change the trigonometric function since you are using the co-ratio rule, and also pay attention to how you represent the quadrant. On a co-ratio rule, we use 270 in this case, or 90, whereby on 180 rule we use 80 or 360. But at the end of the day, you will have the very same answers, guys. The very same answers. I hope you understand. If it so happens that you don't understand what is happening here, do not forget to comment. And also you can also rewatch this over and over again, and also share to your friends. And if there's any other information or any other method that you can use which is easier than this one, you can also leave a comment there. We'll try it and also post it on the videos. Thank you very much, guys, for watching. Till next time, cheers.